here is the exercise. Thank you. I hope it's visible enough. Let me take you through it. O is the center of the circle. Here is a diagram. O is the center of the circle. AB is a diameter. AB is a diameter. Then already once it's given that AB is a diameter, then you know the theorem from grade 11, angles subtended by a diameter at the circumference of the circle is 90 degrees. Therefore it means P1 would be equal to 90 degrees. Already all such information, mark it immediately. Mark it immediately. Let me take you through. O is the center of the circle. AB is a diameter. AB, maybe AC, can I say AC is a diameter, not AB? The diagram is not drawn properly. AC, can I rectify that one? AC is a diameter, not AB. AB is a tangent. Here I've written it handwritten. AB is a tangent of the circle at A. So this AB is a tangent. AC is a diameter. Chord CP. Here's chord CP produced to B. What we prove that AP squared equals to PC multiplied by BP. Just the question, just like that. Slowly look at it. O is the center of the circle. Here is O, the center of the circle. AC is a diameter. Here is AC is a diameter. And if AC is a diameter, already you know that this angle must be 90 degrees. That angle must be P1. Angle P1 must be 90 degrees because it's an angle subtended by diameter. Chord CP produced to B. AB is a tangent to the circle at A. That's AB. It's a tangent. Once you talk of a tangent, I know there are three theorems that should come to our mind. Three theorems associated with tangent. Tan chord, tangent perpendicular to radius, and lastly, tangent drawn from the same points outside the circle are equal in length. But for now, let's look at this one. We want to prove that AP squared is equals to PC multiplied by BP. Thank you. Let's prove. For us to prove this, we need to choose two triangles first and prove similarity between the two triangles. Remember the theorem that we did earlier. If the corresponding sides of two triangles are equiangular, then those sides are proportional. If the corresponding sides of two equiangular triangles are in the same proportion, the corresponding sides of two equiangular triangles are in the same proportion. So let's take two triangles and prove them to be similar. Let's take in triangle ACP and triangle, smaller triangle ACP and triangle ABP and ABP. Let's prove the two triangles to be similar. And remember, to prove that two triangles are similar, you only need to prove two angles to be equal. Two pair of angles to be equal, because the remaining pair will automatically be equal. A triangle is a three-sided figure, three angles. If two pairs of angles are equal from the two triangles, automatically the remaining pair will also be equal. So let's find two angles that are equal in this case. Check. In triangle ACP, angle P1 is equals to 90 degrees. Angle P1 is equals to 90 degrees. Why do I say angle P1 is equals to 90 degrees? Because it's an angle subtended by diameter, or you can say an angle in the semicircle. Check angle P2. If P1 is 90 degrees, what will be the size of P2? Thank you. P2 will also be equals to 90 degrees. Why? Because P1 and P2, those are the angles on a straight line. So they both should add up to 180 degrees. So if P1 is 90, automatically P2 must also be 90. Thank you. Let's go. It means angle P1 is equals to angle P2. Both equals to 90 degrees. First statement. We want to prove in the two triangles, we want to prove them to be similar. And for them to be similar, we need to prove two corresponding angles, two pairs of corresponding angles to be equal. So the first pair, P1 is equal to P2, angle P1 is equal to P2. Secondly, remember AB is a tangent. Then you can see the tan chord. It means angle C will be equals to A2. Angle C will be equals to angle A2. Why? Tan chord theorem from grade 11. Tan chord theorem. Angle between a tangent and a chord is equal angle in the alternate segment. In full, the tan chord theorem states the angle between a tangent of a circle and a chord drawn from a point of contact is equal to the angle in the alternate segment. So, in the two triangles, in triangle ACP and triangle ABP, number one, P1 is equal to angle P1 is equal to angle P2, both equals to 90 degrees. Angle C is equals to A2. So check triangle ACB. We have talked of this angle 90. On this side, that 90. We have talked of this angle to be equal to that one. See, there is one angle that is remaining. So therefore, A1 will then be equal to angle B. Third pair of angles from two triangles. Therefore, those angles must be equal. Now we conclude. Therefore, triangle PCA is similar. Look at the sign for similar. PCA is similar to triangle PC. Angle P goes hand in hand with P. Check angle C goes with A. Then you write A. Then A1 here will go with B. Why do I say triangle PCA is similar to triangle PAB? Because we have proven that angle. This is a condition for two triangles to be similar. Now that we have proven the two triangles to be similar, we can take sides in order. Let's take any two sides in order. Let's say if you take AP over PC, AP over PC. Sorry, I've taken PA or AP over PC. Check on that other side. PA, PB. Because if you take PA, in this side, that must be the ratio. This if you take PC, got PA here. PA or AP. Remember AP, PA, same side. Here is the side if I have to show you. PA or AP, same thing. Now you cross multiply. AP and AP will then ultimately give you, cross multiply, will then give you AP squared. It's AP multiplied by AP, and then here you multiply, then you've got PC multiplied by PB. And this is what we were required to prove earlier on. Prove that AP squared is equal to PC multiplied by BP or PB, same thing. Interesting exercise. For you to master this, you need to practice a lot. One thing that I want to highlight before I go is that two triangles will only be similar if they are equiangular. To prove that two triangles are similar, just prove two pairs of angles to be equal. Then the remaining pair will automatically be equal. And then the order is very much important, because when you have to choose the ratio, order plays a very important role. If the order was not okay, you are not going to end up with the question that we are asked to prove. Very much important. Order is very much important. Like in this case, I said angle P1 is equal to angle P2, angle C is equal to A2, angle A1 is equal to all these angles on this side. This is triangle PCA. Triangle PCA. This other side, PAB, triangle PAB. P associated with P, C with A, and angle A with B. Order is very much important, because once you've taken the sides, those letters in order, then it becomes easy for you to prove that the ratio is the same. On that note, let me take the opportunity to wish you well. And I hope you will practice the Euclidean geometry very hard, because it takes lots and lots of marks. I did what I had to do today, the proof of the two theorems, and also show you the application a little bit. My humble appeal, don't give up. Work hard. Keep on practicing. Remember, practice makes perfect. In case you don't understand, if you've got questions, don't hesitate to go to your teacher. On that note, I wish you well and good luck. Thank you.